Good evening, everyone. I'm Thierry Fautier, Managing Director of Your Media Transformation, based in Silicon Valley. And I'm quite happy to be today talking at the Portland Videotech, and I wanted to thank also my good friend Nicolas Vale for inviting me. And I'm going to talk about live sports streaming at scale, and you'll understand this is not a new topic, but there's still a lot of work to be done. So we'll go through some introduction, the scope of the presentation, live sports streamings in numbers, levers to contain explosion of traffic, architecture, CDN diversity, deployed CDN solution, a tour to Netflix live CDN, what are the alternatives, and some conclusion. So first, I am based in US for the last 25 years in Silicon Valley. I worked at Harmonic for 19 years in various marketing leadership positions. And I was a front runner in many initiatives, IPTV, OTT, Ultra HD, and more recently, CDN SaaS. I'm now the managing director of Your Media Transformation, which is a consulting company helping CDO to grow their business. I'm an active influencer on LinkedIn on media and entertainment related topics, passionate about live sports streaming. So the scope of the presentation, first, I would like to say I will use as much as possible data when available, and sometimes we'll have to do some assumptions. So we'll set the stage for live sports streaming scalability discussion. We'll define the key parameters, define the different types of architecture. Example of deployments will be shared with you. And we'll see there are different ways to skin the cat in terms of scaling live sports streaming. And some conclusion. So let's look at the live sports streamings in numbers. So I've put here the map of all the top events, which are known. And I will start with Peacock NFL playoff in January 24, 16 million concurrent streams and 23 million average measured audience. Of the bitrate of 6 megabits per second, we end up at 96 terabits. Then comes the Netflix global event like the Tyson match, which was 65 million peak sessions, 108 household, we can estimate 216 million average measured audience, assuming you have a TV, doesn't work, you go to your mobile to see if it works better. Bitrate around 6 megabits per second. So here we talk about 390 terabits per second, which is a tremendous number. Looking at the US number, we probably were at 228. Look at what's happening outside US. You have the Disney plus Hotstar Cricket World Cup 2023, 59 session, 0.8 megabit per session, 47 terabits per second. In China, ByteDance concert drew 300 million average user, assuming the peak was around 105. So this is around 42 terabits per second. So what you can see here is you need to look at the peak traffic generated, and this is what is going to dimension the caching infrastructure for the CDN. So what are the levers to contain traffic? First, we start with the compression, codec choice, H.264, HEVC, AV1, and here I want to make the record straight, set the record straight. It is not because you have a brand new codec which is going to address only a few % of your population that you are going to reduce your traffic. You have to reduce the traffic on the most used codecs, which is, unfortunately, in 2024, still H.264. Resolution, 4K, 1080p, even below sometimes. Bitrate dial, you'll see different techniques to reduce the bitrate or to sacrifice the quality like we saw during the COVID. And this is for the head-end part. Now, if you look at the CDN, there are multiple ways to contain the traffic. First, remove the network congestions. On-net caching as much as possible. Of course, this is not always possible. Therefore, you need to put some caches off-net. Elastic caching, in order not to starve from your on-net caching, it's very important to be able to instantiate new caches like you do with a cloud architecture. And of course, for that, you need to have an inherent cloud architecture. Once the content is not available anymore on the on-net caching, you need to cross the peering point. And therefore, you need to have a very good peering connectivity with the different outside of the ISP network. Congestion control, obviously, when the capacity of the caches have reached saturation, you need to reduce the bitrate you serve. And that's what CDN are doing today. Other tricks in gray category, emulate VOD, and we'll see what happened with Netflix later on. Device aware, everybody knows by now that it's not really useful to bring HD, more than HD to mobile. HD is quite good, 1080p, 720p, that's good enough for the mobile devices, especially when you have many mobile devices to serve. User access control here, it's how to limit the number of sessions. So you put a cap, and when you reach the cap, then you cannot serve the incoming session, or you do like Netflix, you hide the menu, and therefore it's not accessible unless you do a manual search into the application. So let's look at the generic CDN architecture. Here you have a content provider putting his origin server across the internet, reaching data centers where some of the caches will be located. That's what we call off-net caches. And then on the ISP network, you will have what we call on-net caches for the traditional public CDN, the content provider caches, the ISP caches, and the open caching caches. In addition, if you're using multicast ABR, you will have to use a multicast network. Delivery is not only about CDN. It also needs to consider ISP and its associated connectivity. Let's look at the different type of CDN architecture currently deployed. The first one is the public CDN, multi-tenant caching service companies. Usual suspect, Akamai, CloudFront, Fastly, Cloudflare, iStroke, Edge.io, which has been going out of business, paid per traffic, and all OTT service except Netflix are using those CDN. The content provider CDN is a dedicated CDN for specific content providers. Like, for instance, if you look at DAZN, Sky, Sony, Bio Broadcaster, TF1, and SVT, some of them are outsourcing the CDN to companies like Mainstreaming or Netscape. Some of them are building their own CDN, and they are managing the CDN as an overlay to the public CDN. The on-net CDN is a category where you try to reuse your private ISP CDN for the OTT traffic. A good example is Cinemedia, which is using that on-net CDN for the Telecom Italia IPTV, which is all ABR, which means HTTP based. And then those caches can be augmented to serve the OTT traffic of large content providers such as DAZN in Italy. The ISP CDN is a CDN service provided by the ISP themselves. And here the logic is for them to leverage the infrastructure that resides inside their network and to offer very good quality of service at a very aggressive pricing. So better quality of service, better pricing, therefore potentially a competition to the public CDN. Here you have the example of Jio in India for the Reliance service, SFR, part of Altis Group, Orange Group deployed in France and other countries, Telefonica in Spain and other countries, Comcast in the US, and Sky in UK. Open caching CDN, multi-tenant caching service with a specification owned by SVTA. Quilt is the front runner on this, and they have Disney Plus as a customer with various ASPs such as BT, Telecom Italia, and Verizon. Multicast ABR, it's a multicast assisted CDN. Obviously, you need a multicast network to be able to use the distribution network, the multicast distribution network. And here we have Telecom Italia and Orange in Spain, who has deployed this type of architecture. So this is what we call CDN diversity. You have 6 different technologies being used, being deployed, and the content provider are basically picking and choosing the type of solution for their content. So if I summarize, we have 3 main categories. Multi-public CDNs used by many content providers, which is today mainstream. Multi-CDN with public CDN plus ISP CDN. This is what we see at companies like Disney, Disney Plus Hotstar, Sky, Canal, DAZN, Amazon. So here you have augmented capacity through caches located inside the ISP network. Multi-CDN with public CDN and private CDN. So here I take the example of DAZN with basically using a third-party CDN to augment the public CDN capacity, but also Amazon with a SAI protocol, developing the SAI software stack that will run on the public CDN caches using the SAI software. And then the single private CDN for very large operators such as Netflix and ByteDance, who decide to cover entirely the traffic using their own infrastructure. So let's look at real life numbers. And I was quite happy to see in 2024, ARCEP, the French regulator, published the ISP traffic for all CDN. So reported figures here are only media and entertainment traffic, excludes other traffic such as Amazon, Facebook, and Google. And this is not counting ISP traffic as it is not crossing the ISP network. And of course, it will not count the on-net caching of the Netflix traffic, which is here we'll only count the off-net cache traffic. So if you look at the numbers, 50% of the traffic is on public CDN. 42% is on the OTT content provider CDN. So in France, it's mostly Netflix and Twitch. So all the companies who have decided to put their own caches. And therefore here you see only 7% coming from the broadcast CDN, the broadcaster who have an OTT offering, obviously, and who are making the content available to their subscribers. So let's look at the different architectures. So the multi-CDN architecture, you all know by now about it, hopefully. I will not teach you anything. So basically, there are multiple competing CDN, and each CDN has a better performance for specific ISP. So the content provider will measure and figure out which CDN to be used with each ISP, and you have multiple CDN, 3, 4, 5. I mean, we tend to see a reduction in number of CDN as opposed to what we saw before. If we take the prime example, obviously you have the public CDN. I put here Akamai as one name, but many others can be used. Then you have the private CDN where Amazon Prime is going to ask some companies to deploy their private CDN in the network. And then on top of that, Prime will have also their own software running on the public CDN infrastructure to provide a different type of caching using the UDP as a SAI protocol. And this is going obviously to be an additional layer of CDN to the public, private, and another private CDN solution. DAZN, starting from the bottom, Akamai, mainstreaming as a private CDN built on purpose for the DAZN that they call DAZN Edge. but also some ISP CDN, such as Cinemedia, caching the content using the on-net caches for IPTV. And of course, Broadpeak will is also participating with multicast ABR. So you see here we have 1, 2, 3, 4 types of technologies for one single content provider. Disney, interesting example of implementation of open caching. So Disney is using multiple public CDN. And then on top of that, they have their own CDN controller who are going to feed the service provider controller that is here managed by Quilt. And Quilt is deploying his own caches inside the ISP network, deployed at BT, Verizon, and Telecom Argentina. So to summarize, on those examples, and I put in addition here the IPTV 2.0, which is the traditional migration from multicast to unicast. And you see for this one, a private CDN, but this private CDN can also be used, as we saw, by Dazen. And then in the private CDN category, we saw that Prime was also able to use some dedicated resource to cache its content. Disney going to open caching, and then Prime going to site. Obviously, this is in addition to the traditional public CDN. So you see that it's a very diverse aggregation of different technologies. Each content provider has decided to go its own way. Will there be convergence? Maybe, but I would like to leave this answer to the market, of course, to my friends at CDN Alliance, who hopefully are going to educate a bit in the future market in this direction. This is what I call CDN diversity, and as you can see, things are moving. Let's look at the Netflix CDN example. So Netflix has decided basically to put different type of caches, one on the ISP network, we call that on-net caches, and one off-net, which is going to serve what we call the long tail content. And in normal conditions, it's about 60% of the traffic is on-net caches for VOD, and off-net is about 40%. But for live, the traffic pattern is very different. We don't have the numbers from Netflix, but we'll see what could be a possibility of what Netflix has deployed. So here, I want to be clear, there is no Netflix official communication on live CDN, but we are going to assume there is a reuse of existing Open Connect CDN architecture for live. The reason is that there are tens of thousands of servers, and to upgrade this infrastructure is going to take many, many years. And the bet Netflix made was try to rely on what exists in order to expand that for the live application, which is for them right now with WWE, probably once in a week. So it's not a big, it's not a good way to invest on 1 or 2 hours a week. It's better to reuse whatever is available and maybe later on move to a different type of architecture. So live has also very different profile than VOD, 50% concurrency versus 5%. And the clearly Open Connect servers were built for VOD and are not optimized for live traffic. So impact is serving live from VOD Open Connect caches is suboptimal. When on-net Open Connect caches are saturated, then need to cross the ISP network to reach off-net caches. If there is a storm of traffic, then it's guaranteed you will have buffering unless ISP can pull 2 to 3x peering capacity, which in most of the case is not the case. Workaround, this was used for NFL, serve live with 2 minutes delay, meaning starting to emulate a VOD protocol as opposed to a live one. This is clearly not an optimal solution. Ideal live CDN, aspiration only. Build a network of high fan-out on-net caches that can sustain peak load. Use a cloud-based MEC, multi-access edge compute, network of servers to increase the capacity on demand for peaks. So here you think that if you cannot plan your capacity, you need to have access to a network of servers that will be hopefully available for your event. But once the event is over, you can release those servers for other tasks. The challenge, of course, is once the live event is cached, need to find workloads to increase cache's usage, such as transcoding jobs, enterprise jobs. So to summarize, the cloud native caching is key, but the business model is also key in that discussion. What are the alternatives? So you have heard about multicast AVR deployed, potential to save 10x traffic, obviously using a multicast network, that makes sense. Client optimization is needed. DAI will be client-based, and DRM is supported today. Peer-to-peer deployed, but some services have been discontinued. Saving versus unicast, we talk here about 70%. Need client optimization and limited device support on DAI and DRM. Good potential, but the devil is always in the detail. To conclude, live sports at large scale is still challenging. Different solutions are applied. Netflix CDN showed its limitation. Ideal solution requires a brand new approach. Alternative solutions are promising, and CDN's diversity will be the norm for some time. I want to thank all of you for your attention. And if you want to reach me, you can follow me on LinkedIn. I'm quite proud to share with you I've reached 1 million views in the last 12 months. Thank you very much, and goodbye.